Saxon Algebra 1 lesson 79. We're going to get fancy in this lesson. And we're just going to talk about the way we write out our problems. For a long time now, we've been using variables, letters that stand for numbers. Then our favorite ones are X and Y. But as you've seen, we can use any letter we want. X and Y are just kind of like the mathematicians' favorites. So we use those a lot. Subscripted variables look a little bit different. These are some that we're going to get used to. And I'll explain to you what's different. Now we're using R's and T's instead of X's and Y's. But what are these little bitty numbers that float down at the bottom? I mean, they don't float, they sink to the bottom, don't they? Those are called the subscripts, written below. That's what subscript means, written below. These variables work exactly like the variables you're used to. We don't do anything special or different. We don't consider them separately. They're just like one nice little package of variables. What you'll see is that subscripted variables are useful for matching the words in a word problem to the numbers in the equations that we built. They help us connect the story to the equation. And that is a very helpful thing. They don't complicate the equation. They just add some details to it to help us remember what the heck we're talking about. In this case, with these R's and T's, R stands for rate and T stands for time. Okay? So that would give us information to help us understand the story. A and M would likely stand for names. Anne and let's say Mary. And we will be doing problems like this, where Anne and Mary are going on trips and we find out about the rate at which they travel and the time that it takes them. So this variable that used to be just RA, before I wrote everything by it, that would be Anne's rate. This would be Anne's time, Mary's rate and Mary's time. We could use X, Y, Z, and W, but this notation style helps us remember what the heck that number means. And once you get the hang of them, you'll realize, oh, they're actually kind of fun. What we're going to do right now is just practice using these without the word problem so that you can get used to them and see how harmless they are. And then in a few lessons, we're going to add in the stories that will make these make a little more sense to you, I think. Right now, you're just like, why are we doing something that makes such a mess? Solve the following system of equations for RA. So that's our information, our instruction. Okay, and we write them down low like that. Okay, and this is what we're given. We're given 4 equations. John writes them across the page. I'm going to list them going down just because that's how my space works better. Oops. Okay, so here are our 4 equations. You'll see that 1 is big and 3 are really short. This is what we call a base equation. And whenever I am talking to you about a base equation, I very often put a star by it. The base equation means that the other equations we get will plug into it, all right? And that's a fairly simple process. What we do is we take the base equation and we put a set of buckets or parentheses for each one of these variables. So I'm going to do that work here. So I'm going to do RA times TA plus RP times TP equals, oh, I'm running out of space, 320. Next time it'll be closer. That's 320. Now we fill in. RP equals 50. Okay, RP goes here. TP equals 4. That goes there. TA equals 3. Now, we don't have anything for this bucket, so we just put the letter inside. Okay? Now I'm going to rewrite this without the buckets. I liked having those in the first place, but now I don't need them. I can write the numbers. And for this first one, I like to have my number before my letter. That's normal. So I'm going to rearrange that as I write it. 3 times, we say R sub A, plus 200 equals, whew, that 320 has some room to breathe finally. We subtract the 200. This is just algebra. 3 times R sub A equals 120. We divide by 3. And we get that the rate of A equals 40. And that's the correct answer. Okay? Now these subscripted variables seem really dumb in this problem because why? We don't even know what they mean. They don't even make any sense to us. That'll come later. John just wants you now to get used to finding the base equation, writing it out with buckets, and then filling in the buckets and solving. All right? Those are our 3 steps. I'm going to write them on the next page. Find the base equation, set it up with buckets and fill them in, solve. So let's write that down on the next page. And then we'll do a total of 4. Yeah. Even though these have 4 fairly different looking equations, this is still a system of equations. So we're technically solving a system of equations. So what are our steps? 1, identify the base equation. 2, write out the base equation. I'm not going to write that over again. With buckets, aka parentheses. 3, fill in buckets and solve. Beautiful. Let's do 79.2. Solve the following system of equations for TR and TT. All right, let's look at that. Here are our equations. This one, this is the base equation. Well, we can tell because it's got all the different letters in it. But it's set up a little differently than last time. That's okay. Don't feel bad about that. I'm going to write these across this time so it doesn't take up as much of my page. Okay, our T equals 2. Our R equals 10. TT equals TR. Okay, so the times are the same. R stands for rates, T stands for time. All right, the lower levels are usually, the lower letters are usually the people who are doing it. Okay, we can see right away, this is the base equation. It's got all the variables in it. And so we're going to set this up with buckets. Our T equals 2, that goes here. Our R equals 10, that goes down here. TT equals TR. Because they're the same, we're going to call both just plain T. This is the time. This is kind of, it's a fairly common thing that in a problem we'll be told that the times are the same. So we can just plug it in with a plain t. That makes it a lot easier. All right, so now we get 2t plus 120 equals 10t. You like it? Then we will subtract 120 equals 8t. Okay, I'm going to divide 120 in half. That's 60. There's two 60s. I'm going to divide 60 in half and say there's 4 30s, right? 2 times 60 equals 120. 4 times 30 equals 120. And then I can chop it in half one more time. 8 times 15. See how my brain sorted through those? So I know that t equals 15. And because I know that they're the same, I can say that tt equals 15, and I can say that tr equals 15. And this would be the most complete way to show my answer. It's true that t equals 15, but let's go ahead and show both of those variables as the problem was originally set up. Okay, so when two of the subscripts match, right, the letter and the subscript, we're told they're the same, we can drop the subscript and say, hey, they both are that. That's like advanced level. We'll do more of those later, but that's kind of hard. Okay, if the t's are the same, we can drop the subscript. All right, let's do another one. I'm a slave driver. Grace is just snoozing over here on the floor. She is being an algebra princess. 79.3. Solve the following system of equations for TL and TS. Okay, so again with the times. So here is, John almost always gives us the base equation first. It's just a nice thing about him. And again, it's sort of the same as what we've seen before, but it's a little different. Okay, but it's got all 4 of the variables in it, so that's our clue. It's probably the base equation. I'm gonna just look. Our L equals 8. Okay, so this is what we're solving for. These are given. This for sure is our base equation. So we can set it up. It's just 2 things times each other. There's no other number in this one. Our L is 8. Our S is 80. I'm just following this pattern in my buckets and filling in. TS, I'm going to write this in. I'm going to substitute this in, just like we've done in other substitution. I'm going to write this in here. This is TS, but I would rather write this TL minus 5, T sub L minus 5. And then here, I'll just leave this as TL. What that does is it gives me just one variable, which means I can solve this. All right? If I wrote TS in here, then I would have 2 different variables. No bueno. So this equation allows me to substitute this in, and then I don't have anything for this, but I'm perfectly happy to leave that as a T sub L because it's beautiful. I'm gonna have to distribute here, aren't I? So I'll get 8 times T sub L equals 80 T sub L minus 400. Good gracious, that's a big number. All right. Oh, this should be, wait, where am I? I feel like I copied something wrong. I did. This is not 8. I completely made that up. This is 40. I just copied the wrong value down for RL. So this is also 40. All right, so I just copied wrong, sorry. All right, so even though it's gonna make a negative number, let's subtract the 80 T sub L. And that will give us minus 40 T sub L equals minus 400. Oh boy, I feel good about that though. T sub L equals 10. Once we get the stories, we'll be saying something like the time of Linda or the time of Louise. It'll make a little more sense. Saying T sub L is kind of awkward. Okay, now we still need to find the time of Susan, let's just say. And we see that the way that we do that is we take the time of Linda, which we know is 10. I'll put it in buckets so you remember we pulled it in, minus 5. So T sub S equals 5. Right? So just like we do with our other systems of equations, once we get one value, we can go back and look at our equations and find out what will help us solve for the other. All right, one more. Are you up for it? 79.4. Solve the following system of equations for R, F, and RE. All right, so Frank and Ernest, perhaps. Here's how we start. Yay. And then we have 3 other equations. I'm going to write them across right here. RF, R sub F equals. Oh. This John's tricky in this one. He writes R sub E equals R sub F plus 15. T sub F equals 16. T sub E equals 12. So, looks like we're going to be substituting this in again. Last time we did it with the T's, this time we were doing it with the R's. Same difference, it doesn't really change anything from an algebra point of view. This is clearly our base equation. This has 2 variables, but this one's got all 4. So this is the grand prize winner. So we set up our base equation using buckets. And then we plug things in. RF, we don't have anything for RF, so we'll just put the RF in. This is RE, so this is what we'll plug in right there. This is RF plus 15. TF goes here, that's 16. TE goes at the end, that's 12. Beautiful. Okay, so if we don't have anything to plug into a bucket, we just put the letters in. That's what I'm saying here. If we have no other value to put into one of the buckets, just put the variable back in. Okay, that's what we did here. All right, I want the number to be first, so I'm doing 16 R sub F equals, oh boy, we have to distribute, and the number we're distributing is on the end. So we'll bring it forward like that. 12RF plus 15 times 12. Let's do that over here. 0 and 3, 1 and 5. 180. Subtract the 12RF from both sides. That cancels. 4 times the rate of Frank, I'm just pretending I made that up, equals 180. Divide both sides by 4. If I divide 180 in half, then I know that 2 times 90 is one set of factors. If I divide it in half again, I get 4 times 45, right? I'm dividing this number in half and then doubling that number. So this is the one that helps me here. I get the rate of Frank equals 45, and then I know the rate of Ernest will be 45 plus 15. So I'll write my final answers here. RF equals 45. R sub E equals 60. Yay! We're going to practice this style of calculation for a few more lessons, and then we're going to get the stories added in to enhance our lives and make these problems that much more fun. I'm excited. I hope you are too. It's going to be great. Thank you. Goodbye.